Okay, so today's topic is line graphs, and since I'm not here, I'm recording this lesson for you instead. So make sure you still take out your line paper and write today's title, today's date, and make sure you copy down today's notes. Okay, so getting started. When do we use line graphs? I want you to write down these notes as I am writing these down as well. I have my pen here. You can see my cursor, I hope, over here. So we usually use line graphs to compare data over time. What do I mean by data over time? Not just data, sorry, I need to add a word, change of data over time. By change of data over time, I mean, for example, if we're looking at Disneyland or Ocean Park, they want to look at the number of visitors, visitors, sorry, that's an O, over each month or maybe over each year. Okay, so that's one way of using line graphs. Perhaps for other shops, they want to look at the number of sales that they get over the years. So sales over the years. And maybe for companies, okay, they want to look at their profit. Company profit over the years again. Okay. Other examples may be the animal people who take cares of animals, or those kind of people. They might want to nature specialists. Okay, they might want to monitor the number of endangered species left. Monitor the number of endangered species over each year again. Okay, so these are many different use of line graphs. Okay, and the really good thing about line graphs is that we can easily see the trends that are happening. So just for example, if I have like a line graph that looks like this, okay, this is a trend that there is a rising trend. Okay, rising trend. Or maybe if your line graph looks somewhat like this, okay, you would say it's quite steady. Whereas if your line graph looks something like this, okay, we would say that this is declining trend. Okay, and these can be very helpful for different people, such as companies, for CEOs, for them, so that they can analyze the data and then change something about what they have to do in their marketing, and so on. Okay, so today we're going to learn how to make a line graph. Okay, so certainly it's not as bad as these examples. So this is just a rough sketch of what I'm trying to say. But later on, we will look at some examples of how to draw a line graph. Okay, so moving on to the first example, let me give you some time to copy this down first. I'll give you a good 5 seconds. Okay, so first example, we have a population table. Okay, so the table below shows the population of Austin County in southeast Texas from 1920 to 1990. And it says make a line graph of the data. So perhaps this county wants to know how they are doing in terms of their population, whether it's doing well or it's declining, and they want to also find out what they can do about it. Okay, first thing we do when doing a line graph, okay, so you might want to first write down some notes, okay? Drawing a line graph. Well, let me do that up here. Drawing a line graph, okay? There are several things that we have to do. First of all, let me do that. One, we need to look at the range of the data. Okay, so we look at range of data. And what do I mean by data? Oh, I should have used red for this one because that was this. This is the data. This is the data. Okay? That is your numbers, the thing that we want to see how it's changing, right? That's the population, that's our data. We look at the range of data, and then we also look at, the smallest value, which is the smallest value. I think that's 13,777. That one's the smallest one. And then we look at the biggest one, look at the range of data, look for smallest data and also largest data. Okay, smallest and largest data. The biggest one is 19,832. So that is my range of data. That is, how much I have to go. Well, the range. Okay, and then second thing, we need to make sure we use ruler, of course. Write down the title of the graph, which is population. Okay, so we need to do appropriate title, labels of axis, label of axis, okay, and then our horizontal axis, which is the x-axis, will be the time. Okay, so this is year over here. So let's go straight into drawing the data. I'm gonna use I have my pseudo ruler here. I need to figure out how to, oh, there, that's kind of cool. Okay, so I have a ruler. I'm gonna draw my line like this, okay? Now, when I look at my data, this is 19,000 is my biggest data over here, okay? So I'm going to put my biggest number as 20,000. I think it's good to round it to the nearest thousand. So I would put this is 20,000, okay? And then maybe I'm gonna go down in if I do 1,000s, then that'll be 20,000, 19,000, 19, 18, 17, 16, 15, 14, 13. I think that works. Okay, so I'm gonna use an interval of 1,000. Okay, so this will be 19,000, 18,000, 17,000, 16,000, 15,000, 14,000, and 13,000. Okay, and then over down here, I'm gonna do that, some sort of a break. Oh, that doesn't really look that nice. It looks kind of like a heartbeat like that, okay? Just to show that I'm not showing any data from 0 to 13,000 because all of the data happens from 13,000 onwards. So over here, we have population. Okay, population. Make sure you label correctly. And then let me take my ruler out again. And I'm going to draw my horizontal axis. Okay. This one will be the years. Okay, I have from 1920, 30, 40, 50, 60, 70, 80, and 1990. So, let me take my ruler away. This will be 1920. and then space them out evenly. Well, let me take up my ruler so I can space it out. Let me do it this way. Oh, I can't make it bigger for some reason. That's fine. 1920, I'll just estimate. 1930, 1940, 1950, 1960, 1970, 1980, and lastly 1990. So I didn't need that much space, that's fine. And then the last thing you do is you plot the data according to the information that you're given. So for 1920, we have 18,874. Let me do this. 18,874 is around here. We can just estimate for this. I'm going to do a dot over there. Okay. And then for 1930, that's 18,860, which is fairly close. Okay. It's fairly close. So it's just slightly, ever slightly so less. Just very slightly less. Okay. So you don't need to reduce it by that much. For 1940, it's 17,384. So 17,300 is around here. Okay. Okay, just plot it down. And then for 1950, it is 14,600. So 14,600 is roughly here. And then plot that. And then 1960 is 13,700, around 13,800. That is around here. And then 1970 is 13,831, so slightly more than before, but very similar. So that's only slightly more. And then for 1980, it rises all the way back up to 17,700. So that's all the way up here. And then last one for 1990, it is 19,832. That's roughly around here. Okay, so we can see that the data changes quite a bit. Okay, and then you can also, the thing about line graphs, now we would probably want to join up these dots, okay, from dot to dot. That's a good thing about line graphs. We will join the lines this time because we are meant to join lines for a line graph. Okay, it's called a line graph because there's a line. Okay, so from here to here, make sure you are also drawing this as I am drawing this. It's easier to draw on paper. Okay, it's not so easy to draw on this tablet. And then to join this up, make sure you use a ruler. Do not use a ruler because we want our line graph to be neat. Last line. Okay, so that's good enough for me. And so two more things I am missing. I need to write down the label down here, which is year, and also the title of the graph, which is population of Austin County I'm just going to leave it at that and then underline as well. Okay, so this is a line graph. Okay, I'm going to leave this here for a few seconds so that you can continue looking at it and copying it down. And then we have some questions to answer based on this graph that we just drew. Okay. So once we're ready, we're going to move on. Okay, so it says here in exercise 5 and 6, let me see if I can move this up. Can I move this up slightly more? Yep. There. Okay, so in exercise 5 and 6, okay, it says use the graph above. Which year was Austin County's population the greatest? Okay, so we can already see there's some sort of trend that it's decreasing here. It's decreasing, and then it's rising again, and it reaches its greatest point up here. So in which year was Austin County's population greatest? That's 1990. And then over which decades did the population have its greatest increase? Okay, increase. So what do I mean by increase? This is the increase that I was talking about. This is increase. And from which years? This I wouldn't, from 1960 to 1970, I wouldn't count it as too much of an increase. It's only a very slight increase, so that doesn't really count. The place where it really counts is between this all the way to here. Okay, that's the biggest increase. So what is that? That is from 1970 to 1990. 1970 to 1990. Make sure you copy down these two questions in your notes as well so that you can answer the question and see in your notes in the future as well. Moving on, we have one more question. I'll see if I can draw the graph faster. We have a very cute cat over here. Very cute. Okay. And then, so question 7. The table below shows the number of pet cats in the United States from 1933 to 2003. Make a line graph of the data. Now, I'm going to change this question up a little bit. I'm going to say pet cats in United States and Canada. Okay, I'm going to change it up a bit. Here, it's not just cats. This is in millions, but this one is for US, and then cats in Canada, CAD. Okay, I'm going to add an extra an extra row to this question. So I'm just going to make up these numbers. Let's say it starts off at 70 and it goes to 72 and it goes down to 68, 65, and then it goes back up to 71 and then 74. Okay, just an example. So please copy down the question in United States and Canada, okay, from 1993. So instead of a line graph, this will be make a double line graph. Okay, it's going to be a double line graph. I'm going to start off by setting my graph. Okay, the range of data goes from roughly around 80. This is the biggest data, around 80. So around 80. And the smallest one is 64, which is, I'll say, around 60. Okay, from 60 to 80. And maybe I will go up in fives. Okay, so if I have 80 up here, and 75, 70, 65, and 60. Okay, it's nice and small. Maybe I can double it. Okay, make it bigger. 1, 2, 3, 4. Okay, so this should be, and remember to do that thing. Okay, this will be 80, 75, 70, 65, and 60. Okay, let me do my ruler horizontal. And how many years do I have to do from 1993? So I'm going to label this 1993, 1994, 1995, 1996, 1997, 1998, 1999. Oh, no, it skipped years. Whoops, my bad. I was wondering why there was so much. 1995, 1997, 1999, 2001, 2003. That's it. Okay. Now, the important thing about line graphs is that for double line graphs, if we have two types of data, one is US, one is Canada, we're going to use different colors. Okay. So I'm going to use blue for my US data, which is the top row. In 1993, we are at 64 around here. And then in 1995, it goes up to 66 around here. 1997, it goes up to 70. And then 1999 is 73, which is around here. And then 2001, 76. Which is here, and then 2003 we have 78. So we can see it keeps on rising, it keeps increasing. Okay, and then do you use a ruler? I'm not going to use a ruler because it takes too much time for me. So you join up all these points. Okay, so and in the side, make sure you have a legend. This will be US cats. Okay, and then for green will be CAD, Canada cats. Okay, for Canada it starts up at 70 and then it goes to 72 around here, and then 68 it drops down, and then 65 drops down even more, and then it goes up to 71, and then 74. Okay, and then lastly, you again join the lines with a ruler. Okay, so here we have what we call a double line graph. Last thing I need to do, which is also very important, is you need to write the label. This is cats in millions, and then at the bottom here we have year, and at the top it is the title, pet cats in the US and in US and Canada, CAD for short. Okay, and then underline your title. So this is a double line graph. Now make sure you do copy this down as well, and once you're done copying, I will give you your homework questions, which is we're not going to do example 3 because actually we can. One more example. Okay, so this one we don't need to draw, but in this example we have, I just want you to listen and think about this as well. There are two graphs, okay, two below, showing the number of radio stations in the United States. The first one uses a full scale. What do I mean by full scales? It goes from 0 all the way to the highest data. Okay, that's what we call a full scale. scale. And then for the one on the right, it cuts off the data, just like what we did a while ago, to the relevant numbers, okay? Because there's nothing, you can see that there is nothing here, nothing, no data to show. It's not very interesting. We can't really see the trends. Whereas if we cut off the data, not cutting off the scale, we can see more of a trend. You can see that it's kind of going down here, and then it's kind of steady, and then it does its patterns, okay? So you can see more trend, it's more clear, okay? Whereas in the left side, it looks like there's nothing happening. Everything is steady, okay? So, yeah, that's the two types of scales. One is a full scale, the second one is a broken scale, okay? So this is a broken scale. Okay, so both have its uses, okay? Some are more useful than others. Sometimes we use the one on the right to show the changes more clearly. However, sometimes we use the one on the left to show that it's been very steady all along, okay? There's no drastic change over the years, okay? So your homework questions are here, 2.6, questions 15, 16, 19, 28, 29, 30, 31, and 32. Make sure you use ruler to draw all graphs, draw neatly, and hand in your homework next lesson when I see you. Goodbye.